In this demonstration, I will present the main services and functionalities of our Neuroclima conversational platform. When users open the website, they can access all available services from the main interface. One of the core services is the Climate Conversational Agent. To use the chatbot, users are required to log in through the System Hub. This ensures secure access to the platform. Users are also asked to provide consent for data usage. Essential services are required for the system to function properly. In addition, users may optionally allow their interaction data to be used for research purposes and to further improve our AI models. The application currently supports 4 languages: English, Italian, Portuguese, and Greek. The platform also provides 2 reading modes to support different user needs. A simple reading mode presents concise and easy-to-understand answers for general users, while an advanced reading mode offers more detailed explanations and in-depth information for expert users. Let us start by asking a question. Once the question is submitted, the system retrieves relevant information and generates a complete response. Here, the platform uses a dual retrieval approach that combines traditional retrieval-augmented generation and GraphRag. This hybrid method allows the system to gather both document-based evidence and structured knowledge graph insights to produce more accurate and context-aware answers to the user's question. Below each response, users can view the reference documents that were used to generate the answer. These references provide transparency and allow users to verify the reliability of the information. The system also includes an online evaluation mechanism. For each response, users can see a confidence score that reflects the reliability of the generated answer. By clicking the Help button, users can learn how this confidence value is calculated. It is based on several evaluation metrics, including response groundedness, contextual relevance, and answer quality. Users can also click the More button to view the average confidence score along with detailed evaluation metrics. The system evaluates core confidence indicators such as groundedness, answer relevance, and other quality measures. Next to each metric, users can click an arrow icon to access explainability features, which provide a chain-of-thought-style overview of how the response was generated. Another important feature is the social tipping point analysis. A social tipping point refers to a situation where small social or behavioral changes can lead to rapid and large-scale societal transformation. Here, users can see the relevant social tipping points associated with the generated response. In some cases, a response may include one, while in other cases, no tipping point may be identified. The system identifies such insights using a trained classifier based on 5 key evaluation factors. These factors are displayed together with each tipping point insight to explain the reasoning behind the classification. Users can further explore the knowledge behind each response by clicking the Explore button. This opens an interactive knowledge graph generated from the most relevant reference document. For first-time users, the system provides a complete guidance panel explaining how to navigate the knowledge graph. A knowledge graph is a structured representation of information in which entities such as people, organizations, events, and technologies are connected through meaningful relationships. This structure helps users better understand how different concepts are linked and supports deeper exploration of complex information. In the visualization, each color represents a different type of entity, while animation direction illustrates the flow of connections between them. The direction of the links helps users understand how information moves across the network, and the width of each connection visually indicates the strength or significance of the relationship. Users can filter entities by category and switch to a 3-dimensional visualization mode for a more immersive exploration experience. In the 3D space, users can see connections more clearly and easily, which helps them better understand the overall structure of the network. Additionally, by clicking on each tab, users can access more detailed information. The Entities tab provides a complete list of all identified entities, and users can download the entire knowledge graph to their computer or download data from individual tabs. They can also filter or search for specific information. The Relationships tab displays all connections between entities, along with descriptive explanations. The Communities tab presents clusters of closely related entities and their relationships, which are automatically detected within the knowledge graph to help summarize large datasets. The Claims tab identifies and extracts specific factual statements from the source documents. Finally, the Report tab automatically generates structured, human-readable summaries of the knowledge communities found within a data file. Now, let us go back to our previous conversation and ask a follow-up question. When users ask a new question, previous reference lists and tipping point insights are automatically collapsed to maintain a clean chat interface. The system also supports follow-up questions and maintains the conversation context. Now, as I ask a new question, let us check whether our bot actually provides the correct answer. It indicates a 38.8% increase, and our evaluation system has rated this response as 93% accurate. Now let us click on the reference document to verify where the answer comes from. Yes, we can see that the response is correctly supported by this news article, which is excellent. Users can copy responses to the clipboard, listen to responses using speech synthesis,
international coffee prices significantly increased,
and provide feedback using thumbs up or thumbs down buttons. This feedback supports continuous system improvement. Let's now ask a question without providing any explicit context. For example, what was the main reason for this rise? As you can see, this is a follow-up question that does not directly mention the topic. This helps demonstrate the intelligence of the chatbot. The system is able to understand what this rise refers to by using the session memory from the ongoing conversation and then provides a relevant answer. This is possible because the backend includes a question improvement component that refines the user's query using conversational context before retrieving the most appropriate documents. As you can see, the system understands the question and provides an accurate and relevant answer, which is very impressive. Now, let us also try a conversational input that is not related to climate topics. For example, I can say that I feel sleepy. The system recognizes that this is a general conversational query rather than a knowledge-based climate question. Instead of searching through documents unnecessarily, the chatbot understands the intent and provides an immediate, friendly response. This demonstrates the system's ability to handle both domain-specific questions and natural conversational interactions. Let us see how we secure your personal data in the bot. In the menu bar, you can see a session timer that is responsible for automatically deleting your data when you are inactive in order to support GDPR compliance. While you are actively working in the session through mouse movements or clicks, the timer continuously resets and you are given a 10-minute active window. However, once you become inactive, the session timer starts counting down from 10 minutes to 0, after which all session data is removed. During the final minute, a warning pop-up appears on the screen reminding you to remain active, otherwise your data will be deleted. Even refreshing the page will result in the deletion of all session data. Now that we have explored the conversational features, let us move on to discover the other functionalities available to users within the system and continue navigating the platform. The platform also includes a user analytics dashboard. Here, users can view statistics such as total user questions, frequently used documents, and trending keyword clouds. In addition, administrators have access to advanced dashboards that provide more powerful features to maintain and manage the chatbot without requiring any technical knowledge. These dashboards offer clear insights into document processing workflows, including chunking statistics, extracted elements, and the processing status for each dataset. The platform also includes multiple monitoring dashboards that provide insights into system performance, response speed, and other operational metrics. Custom dashboards allow administrators to closely monitor the application in real time. They can track how each user query is processed through the backend, identify which services are involved, observe the data entering and leaving each service, and review the total processing time for every request. These tracing capabilities support transparency and system optimization. If users do not provide consent for analytics services, their interaction data will not be stored in these dashboards, and the evaluation components will also be disabled. Finally, a LLM performance dashboard displays request volumes, success rates, token usage, and operational costs. These analytics support system optimization and resource management where administrators can control and manage all deployed models. Currently, the platform uses locally deployed models for core operations, while paid GPT models are used for evaluation purposes. Administrators can easily add and manage their API keys, monitor model usage, track token consumption, and analyze the overall cost of GPT API services directly from this dashboard. Overall, this platform demonstrates how AI-driven conversational technologies can support climate knowledge access, transparency, and informed decision-making. Thank you for watching this demonstration. We look forward to seeing you again with new and innovative developments in the future.